The governor's transport sat in the subterranean garage like a granite monolith, a 6-ton promise of safety turned into a prison. The electronic deadlock system had failed in the secure position, sealing the VIP inside a warming cabin. Modern diagnostics showed absolute perfection, green lights everywhere, yet the doors remained fused to the frame. The manufacturer's team was minutes away from taking hydraulic cutters to the B-pillar, a destructive act of desperation. That's when Camilla arrived, carrying a heavy canvas tool roll instead of a diagnostic tablet. The garage was a concrete echo chamber, amplifying the panic of 20 security agents into a deafening roar. Radios chirped with frantic status updates, and the sharp bark of the detail leader cut through the recycled air. But in the center of that chaos, the limousine sat in heavy, judgmental silence. This wasn't a luxury sedan. It was a custom-built, heavy-duty platform wearing a tuxedo. 9,000 pounds of hardened steel, ceramic composites, and ballistic glass, designed to stop a high-velocity round, had now decided to stop its own passengers from leaving. It sat on its suspension like a sleeping giant, utterly unimpressed by the humans scurrying around its perimeter. You have to understand the specific nightmare of Fortress Mode. It's a proprietary security protocol designed for ambush scenarios. When triggered, it doesn't just lock the doors. It mechanically disengages the exterior handles from the latch assemblies and isolates the electronic control units to prevent digital hacking. It turns the vehicle into a sealed vault. The problem is, a vault needs a key, and right now, the digital key was screaming that the door was already open. The system believed it was compliant, while the physical bolts remained driven home. A team of 3 manufacturer-certified technicians swarmed the hood, their faces pale in the harsh fluorescent light. They were frantically cycling the power, plugging and unplugging OBD3 scanners, looking for a software bug that simply didn't exist. They were chasing ghosts in the code, convinced that if they just found the right line of programming, the physical world would fall back into line. They treated the machine like a smartphone that needed a reboot, ignoring the massive physical reality of the steel surrounding them. They were looking for logic errors in a system that was suffering from a mechanical seizure. Camilla viewed the panic with the detached professionalism of someone who had spent 30 years diagnosing industrial failures. She didn't look at the screens. She didn't ask what the error codes were. She knew that when a machine this complex goes silent, the truth isn't on a display. It's in the metal. She watched the lead technician slam his palm against the fender in frustration, a gesture of impotence against the mechanical indifference of the car. They were interrogating the computer when they should have been listening to the chassis. To her, the car wasn't broken. It was holding its breath, waiting for someone who spoke its language. The air in the garage was getting stale, heavy with the smell of exhaust and anxiety. The lead security agent, a man whose suit was straining at the shoulders, finally snapped. He pointed at the rescue squad standing by with the hydraulic spreaders, the jaws of life. He was done waiting for the nerds to fix the code. He was ready to tear the vehicle apart to get his principal out, regardless of the cost or the damage to the structural integrity of the frame. He saw the car as an obstacle to be breached, not a system to be understood. Camilla stepped forward, her boots making a distinct, rhythmic sound on the oil-stained concrete. She didn't shout. She didn't run. She simply walked past the technicians, past the shouting agent, and placed her hand flat against the rear door seam. She closed her eyes for a second, feeling the temperature of the metal, the tension held within the panel gaps. "If you cut that pillar," she said, her voice low but cutting through the noise with the precision of a scalpel, "you'll warp the frame rails and jam the deadlock permanently. You won't get him out. You'll just seal him in a twisted cage." The security lead froze, his hand half raised to signal the breach. The technicians looked up from their screens, blinking like moles dragged into the sunlight. They saw a woman in coveralls with graying hair tied back in a severe knot, holding a roll of tools that looked like they belonged in a steam locomotive repair shop, not a digital diagnostic center. She wasn't looking at them. She was looking at the seal where the door met the body, seeing something invisible to the sensors. The lead technician moved to block her path. He launched into a rapid-fire explanation of the body control module, insisting that the encrypted handshake between the door actuators and the central processor had failed. His solution was a hard system reset, a process that would kill the climate control for 3 minutes while the computers relearned their identity. He was proposing to cut the air supply to a sealed, armored box, all to chase a software ghost. The security lead, however, had stopped listening to the technical jargon. He cared only about the extraction timeline. He signaled the rescue team to bring the hydraulic spreaders forward. These tools are designed to shear through standard automotive steel like it is wet cardboard. But this limousine was not built from standard steel. It was a cage of military-grade composite armor. Attempting to force-feed a hydraulic wedge into that door gap would unleash 50,000 pounds of spreading force against the B-pillar. It would twist the unibody frame, potentially pinching the hardened steel pins even tighter. They were moments away from turning a $2 million asset into a pile of twisted scrap. And worse, they risked torquing the chassis so severely that the door would fuse permanently, turning a rescue into a prolonged cutting operation. Camilla didn't argue with the suit or the technician. She simply stepped around them and placed her palm flat against the B-pillar, right over the hidden location of the deadbolt assembly. She closed her eyes for a moment, tuning out the shouting, the radio chatter, and the hum of the garage ventilation. She waited. When the technician tapped unlock on his screen again, she didn't look for a green light. She felt for the thrum in the steel. A faint, almost imperceptible vibration traveled through the armor plating, a shudder that started strong and died instantly. The machine wasn't confused. It was terrified. The Fortress Mode protocol had driven the tungsten locking pins into their receivers with such violence that they had become one with the frame. It was a mechanical panic response. Think of a muscle cramping. The brain sends the signal to relax, but the fibers are locked in a chemical bind, fueled by their own tension. The solenoids were trying to pull the pins back, but the friction of the metal-on-metal contact was higher than the magnetic force of the retraction coils. The car was seizing. It was holding the door shut with the desperate strength of a drowning man gripping a lifeline, and no amount of software code could convince a cramp to release. This was the blind spot of modern engineering. The sensors were Hall effect switches, simple magnetic proximity detectors. They could tell the computer if the pin was in or out. They could not report how hard the pin was wedged against the receiver plate. They couldn't measure the stiction, the static friction coefficient that skyrockets when two smooth metal surfaces are pressed together under tons of pressure. The computer saw locked and sent the unlock voltage. The voltage went to the solenoid. The solenoid pulled. The pin didn't move. The computer timed out because it had no sensor for physically stuck. It was a digital mind trying to solve an analog problem. Camila walked back to the chase car and unrolled the canvas kit on the hood. She pulled out a mechanic's stethoscope and a non-contact infrared thermometer, tools that measured the physical reality of the world. She wasn't there to debug the software. She was there to treat the paralysis. To understand the paralysis holding the governor hostage, you have to look past the leather and the wood grain to the brutalist engineering hidden inside the B-pillar. This vehicle utilizes a tungsten carbide deadbolt system, a mechanism originally derived from the locking protocols of bank vaults rather than automotive design. In a standard vehicle, a door latch is a simple claw that grabs a striker loop. But in the Beast, when Fortress Mode engages, 4 cylindrical pins, each the diameter of a thumb and machined from hardened alloy, are driven pneumatically and held magnetically into reinforced receiver plates in the frame. These pins are designed to withstand the lateral impact of a rocket-propelled grenade. They are built to keep the door sealed even if the vehicle is tumbling down a ravine. The engineering intent is absolute structural rigidity, prioritizing the integrity of the seal above all else. However, in their pursuit of ballistic invulnerability, the designers had neglected a variable that is far more common than an RPG attack: the thermal dynamics of a subterranean garage. The flaw was a matter of microns. The vehicle had been sitting on the tarmac in direct sunlight for 3 hours before the transport, soaking up heat, the black armor reaching temperatures that expanded the metal chassis. Then, it was driven rapidly into this underground bunker, where the ambient temperature was a steady, cool 60 degrees, 15 degrees colder than the street outside. As the vehicle sat in the static silence of the garage, the massive thermal mass of the armor began to shed heat. The steel contracted. The receiver plates in the frame shrank by a fraction of a millimeter. The tungsten pins, however, being a different density and buried deep inside the insulated door, held their heat longer. You had a hot, expanded pin sitting inside a cold, contracting hole. The clearance gap, designed to be razor-thin for security, had vanished entirely. The pin was no longer just resting in the receiver. It was being crushed by it. Camila placed the diaphragm of the stethoscope against the painted metal of the pillar, right over the hidden solenoid assembly. The cold of the steel radiated through the instrument, a tactile confirmation of the thermal shift. She signaled the lead technician with a sharp, commanding gesture. "Hit the unlock command, now." The technician, rolling his eyes at the theatrics, tapped the screen. To the naked ear, there was silence. The heavy insulation of the limousine swallowed the mechanical noise. But through the stethoscope, Camilla heard the story clearly. She heard the sharp click of the relay engaging, followed by a low, straining hum. The sound of high-torque electric coils flooding with current, trying desperately to generate the magnetic field required to retract the pin. The hum held for exactly 2 seconds, rising in pitch as the resistance held firm, and then cut out with a dull clunk. It was the auditory signature of an electrical stall. She had heard this exact sound 1,000 times before, usually while standing knee-deep in mud, working on the hydraulic proportional valves of heavy excavators. When a valve spool gets hot and the casing gets cold, the metal binds. The solenoid pushes with all its might, but the friction of the interference fit is absolute. The computer, sensing the spike in amperage as the motor stalls, cuts the power to prevent the wiring from melting. That was the clunk. The system wasn't failing to send the signal, it was failing to overcome the physics of the bind. The computer reported "open" because the relay had fired, but the sensor that confirmed the pin's position was likely jammed or misaligned by the same thermal squeeze. She pulled the stethoscope from her ears and let it hang around her neck, the rubber tubing stark against her coveralls. The technicians were already starting to explain that the sensors were reading a state change, proving that the software had done its job. They were arguing with reality, holding up their tablets as if the data stream could override the physical fact that the door was still shut. Camilla looked at them, then at the sweating security lead. "The computer isn't hallucinating," she said, her voice flat and certain. "It's trying to open the door. But your locking pins are in a thermal interference fit. The solenoid is pulling, but the metal has cold welded itself into the receiver. You can reboot that computer until the battery dies. You can rewrite the code from scratch. It won't matter. You are trying to talk a rock into moving." The silence that followed was heavy. The lead technician scoffed, crossing his arms. "That system is rated for Arctic conditions. A 15-degree drop is within operating spec." "For the electronics, yes," Camilla countered, stepping back to her tool roll. "But not for the tolerance stack up on a custom build that's been heat-soaked. You have a physics problem, not a data problem." She reached into her canvas roll and bypassed the wrenches, the screwdrivers, and the pry bars. Her hand closed around the grip of a tool that had no place in a modern automotive repair bay, a tool that implied destruction rather than repair. As she lifted it, the blue tank of the butane torch caught the fluorescent light, and a ripple of genuine horror went through the security detail. She wasn't planning to hack the car, she was planning to cook it. The reaction to the torch was immediate and visceral, a reflex born of modern safety protocols colliding with archaic methods. The moment the blue cylinder appeared, the garage transformed from a confused repair bay into a hostile standoff. The lead security agent didn't just object, he physically interposed himself between Camilla and the vehicle, his hand hovering near his belt, treating the butane canister as if it were an improvised explosive device. In his world, fire was an uncontrolled variable, a chaotic element that had no place near a sealed environment containing a high-value principle. He saw a flame, he saw a threat. The manufacturer's technicians were equally horrified, though for different reasons. To them, the application of open flame to a composite armored body panel was a violation of every service manual ever written. It was the equivalent of performing brain surgery with a stone axe. Their objections were not entirely without merit, at least on paper. The beast was not just a car. It was a rolling chemical stockpile. The B-pillar encapsulated high-pressure oxygen lines for the emergency breathing system, the fuel filler neck for the explosion-suppressant gas tank, and the complex wiring harness for the encrypted communications array. Applying heat to that specific junction was, according to the manufacturer's schematic, an act of insanity. The lead technician began shouting about thermal runaway, about the risk of melting the wire insulation and shorting the entire electrical bus, which would not only fail to unlock the door, but could deploy the fire suppression system, suffocating the occupants in a cloud of halon gas. They viewed the car as a delicate ecosystem of volatile systems, and Camilla was proposing to introduce a wildfire. Camilla waited for the noise to subside, her expression unchanged, the unlit torch resting casually in her hand like a baton. She didn't shout back. She didn't try to argue with the safety manual. She simply waited for them to run out of breath. When the silence finally returned, heavy with the threat of violence, she spoke to the physics of the situation rather than the politics. She spoke to the physics of the situation rather than the politics. "I need 50 microns," she stated, holding up her thumb and forefinger. "That is the thickness of a human hair. The receiver plate is the cage. The pin is the prisoner. If I heat the cage, the steel expands outward, away from the pin. I am not burning the car. I am asking the metal to make room." The technician shook his head, retreating into his professional comfort zone. He called her a liability, dismissing her as a relic who didn't understand the complexity of modern composite integration. He used the term backyard mechanic like a slur. That was the mistake. That was the moment the dynamic shifted. Camilla stepped closer, invading his personal space not with aggression, but with the sheer weight of her experience. She looked at the tablet in his hand, then at the stalled machine behind him. "You are a parts changer," she said, the insult landing with the heavy thud of a dropped wrench. "You are trained to identify a failed module and swap it for a new one. You follow a flow chart. If the chart says replace, you replace. If the chart says error, you panic. But there is no module to swap here. The metal has physically moved. You cannot code your way out of a physics problem. This is not a computer error. It is a metallurgy problem. And right now, I am the only one here who is listening to what the steel is telling us." She turned to the security lead, who was still blocking her path, and delivered the ultimatum that stripped away the bureaucratic insulation. They had two choices. They could spend the next 20 minutes setting up the hydraulic rescue tools, a violent process that would guarantee the total destruction of the vehicle's frame, likely shatter the ballistic glass, and potentially traumatize the occupants with the sound of tearing metal. Or they could give her 5 minutes with the torch. 5 minutes to apply precise, controlled heat. 5 minutes to ask the car to let go, rather than forcing it. "He's getting hot in there," she added, nodding toward the tinted window where the governor was undoubtedly sweating through his suit. "And your hydraulic cutter is still in the case." The decision didn't come from the security lead or the technician. It came from the shadows near the elevator, where the governor's chief of staff had been watching the stalemate with mounting desperation. He was a man who understood risk management, and he saw the difference between a team that was reading a manual and a woman who was reading the situation. He stepped into the light, wiping a sheen of sweat from his forehead, and looked at the specialist. He didn't ask about the warranty. He didn't ask about the oxygen lines. He asked one question. "Can you open it without killing him?" "Yes," Camilla said. "Give her the torch," the chief of staff ordered, his voice cracking slightly. "You have 5 minutes. Then we cut the car." The security lead stepped aside, his face a mask of furious compliance, leaving the path to the B-pillar open. The heresy had been sanctioned. Camilla approached the B-pillar with the deliberate, measured cadence of a bomb disposal technician approaching a live device. She reached into her canvas roll and retrieved a tube of industrial thermal paste, a silver-gray ceramic compound typically used to seat heat sinks onto high-performance computer processors. To the horrified onlookers, it looked like she was about to smear grease on a paint job worth more than their annual salaries. But to a specialist, this was the creation of a thermal dam. She squeezed the compound onto her gloved finger and began to paint a precise, thick rectangle around the door seam, framing the hidden location of the receiver plate. She wasn't just protecting the glossy black finish from the open flame. She was creating a physical barrier to control the migration of the heat. She needed the thermal energy to travel inward, into the heavy steel of the frame, not outward across the surface of the body panel. She applied the paste with the focus of a surgeon prepping an incision site, ensuring the layer was uniform, knowing that any gap in the compound could lead to a blistered clear coat, or, worse, uncontrolled heat spread that would skew her expansion metrics. She stopped, her hand hovering over the metal, and turned to the security lead. The garage was filled with the low hum of the building's ventilation system, the static crackle of radios, and the nervous shuffling of feet. "Kill the fans," she ordered, her voice flat and non-negotiable. "And tell your men to stop moving. I need absolute zero on the audio." The lead agent started to protest. Shutting down ventilation in a secure garage was against protocol, but the chief of staff nodded. The fans spun down. The radios were silenced. The garage fell into a heavy, suffocating quiet. Camilla didn't demand silence for dramatic effect. She demanded it for telemetry. When steel is subjected to rapid thermal expansion, it doesn't just grow, it speaks. The crystalline structure of the metal shifts, releasing stress in microscopic increments that create a specific, high-frequency tink sound. She needed to hear that sound to know the metal was moving. If she missed the auditory cue, she would overheat the assembly. The risk of overheating was the shadow hanging over the entire operation. The B-pillar of a modern armored limousine is not a solid block of steel. It is a hollow structural member packed with the nervous system of the car. Running directly behind the receiver plate was the main body wiring harness, a thick bundle of copper strands insulated in cross-linked polyethylene. This loom carried the data signals for the airbag sensors, the voltage for the window motors, and, critically, the trigger lines for the fire suppression system. The melting point of the wire insulation was only a few hundred degrees lower than the target temperature for the steel expansion. It was a blind contour. She had to heat the steel enough to expand the receiver hole by 50 microns, but stop exactly before the heat soaked through to the inner cavity and melted the insulation. If she crossed that thermal line, the wires would fuse, the deadbolt would be permanently electrically seized, and the cabin would fill with toxic, acrid smoke from the burning plastic, choking the governor inside his fortress. She picked up the butane torch, a vintage unit with a brass mixing valve that offered granular control over the gas flow. She didn't ignite it immediately. Instead, she adjusted the venturi, listening to the hiss of the gas, tuning the mix to produce a lean, oxidizing flame. She didn't want a bushy yellow flame that would wash heat over a large area. She needed a tight, blue cone, a needle of thermal energy that she could drive into the steel with pinpoint accuracy. The flame needed to be hot enough to shock the surface metal, but focused enough to prevent the heat from bleeding into the surrounding armor before it could do its work. She tested the flow against her hand, feeling the pressure of the gas, ensuring the delivery was consistent. The atmosphere in the garage shifted from chaotic panic to a singular, razor-sharp point of focus. The technicians, the agents, and the staff were no longer looking at their watches or their tablets. They were fixated on the small, brass tool in her hand. The skepticism was still there, thick as the exhaust fumes, but it was now mixed with a morbid curiosity. They were watching a high-wire act where the safety net had been removed. The digital world of sensors and codes had failed them, leaving them suspended in this analog moment, dependent on the intuition of a woman who measured temperature by color and tension by sound. Camilla pulled a pair of Tint 5 welding goggles from her pocket and slid them over her eyes, the world turning into a dark green monochrome. She struck the igniter. The torch snapped to life, not with a roar, but with a sharp, aggressive hiss. The blue flame stabilized instantly, a perfect, inch-long cone of focused energy glowing in the gloom. She didn't hesitate. She stepped in. Camilla lowered the flame toward the B-pillar, stopping exactly 1 inch from the surface of the thermal paste. She didn't hold the torch static. That would have been catastrophic. Instead, she began a rhythmic, orbital motion, sweeping the fire in a tight, widening spiral that mimicked the heat dissipation patterns used in aerospace welding. She was painting with temperature, layering the thermal energy into the steel in thin, controlled washes. The gray paste sizzled instantly, turning a chalky white as the volatiles evaporated, forming a sacrificial crust that shielded the glossy black finish while conducting the intense heat into the armor plate beneath. Her left hand remained pressed flat against the chassis, 6 inches below the heating zone. To the uninitiated, this looked like a shamanistic ritual, a laying on of hands. To a specialist, it was the only reliable telemetry in the room. She was using her palm as a thermal probe, monitoring the rate of conduction. The heavy armor of the beast was designed to dissipate energy, whether from a bullet or a blast, so it was sucking the heat away from her target area with incredible efficiency. She had to overwhelm that thermal inertia without losing control of the gradient. She needed the frame to get hot, but she needed the wiring harness inside the pillar to stay cold. It was a race between the expansion of the steel and the melting point of the polyethylene insulation, and she was running it by feel. Then, the car began to speak. A low, resonant groan emanated from the B-pillar, a sound like a submarine hull compressing at depth. It was a subsonic vibration that you felt in your teeth more than you heard with your ears. The lead technician flinched, taking a half step back, convinced that the structural glass was about to shatter or that the frame was buckling under the thermal stress. He opened his mouth to shout a warning, to demand she stop the destruction, but Camilla didn't even blink. She knew that sound. It wasn't failure. It was relief. It was the sound of the crystalline lattice of the steel rearranging itself, the microscopic grain structure expanding and sliding against the friction of the sea's deadbolt. The metal was waking up. 3 minutes, the security lead announced, his voice tight with the pressure of the timeline. He was staring at his watch, counting down the seconds until he would order the hydraulic breach. Camilla filtered his voice out, treating it as background noise, no more relevant than the hum of the overhead lights. Her world had narrowed down to the color of the heat. She wasn't looking for the cherry-red glow of forging steel. That would mean she had gone too far and destroyed the temper of the armor. She was looking for a subtle shift in the texture of the thermal paste, a specific dulling of the surface that indicated the metal underneath had reached 300 degrees Fahrenheit. This was the black heat zone, invisible to the naked eye, but screamingly hot to the touch. The heat was migrating now. She could feel the vibration of the expansion traveling through the chassis into her left hand. The interference fit, that brutal molecular lock between the pin and the receiver, was fighting a losing battle against the laws of thermodynamics. The receiver plate was a ring of steel, and as it heated, it had no choice but to grow. The geometry was expanding outward, fighting the compressive force of the cold garage. She kept the torch moving, widening the spiral, chasing the cold spots, forcing the energy deeper into the throat of the lock mechanism. 2 minutes, the voice barked. The garage felt smaller now, the air thin. The smell of heated ceramic paste and warm metal filled the space, a sharp industrial scent that overrode the exhaust fumes. The technicians were silent, paralyzed by the sight of the flame licking the side of a vehicle they were forbidden to even scratch. They were watching a violation of their entire professional reality. Suddenly, the feedback changed. The vibration under her left hand shifted from a continuous, strained hum to a series of rapid, microscopic stutters. It was the stick-slip phenomenon, the friction breaking. The receiver plate had expanded just enough to break the cold weld. The tungsten pin was no longer crushed, it was merely resting. She had reached the yield point. The physics had aligned. The gap was open. Camilla killed the gas valve instantly. The hiss of the flame died, plunging the garage back into a ringing silence. She ripped the goggles from her face and locked eyes with the driver through the partition glass, her hand raised in a sharp chopping motion. "Unlock," she commanded. "Now." The driver's finger pressed the unlock switch on the armrest, a simple mechanical input that had failed a dozen times in the last hour. But this time, the response wasn't the mocking silence of a digital timeout or the chirp of an error code. There was a sound that you felt in the soles of your boots before you heard it with your ears, a heavy, percussive thunk. It was the sound of 4 hardened tungsten pins retracting simultaneously, driven by high-torque solenoids that had finally found the clearance they needed to move. It wasn't the polite, dampened click of a luxury sedan. It was the heavy, industrial report of a bank vault cycling its tumblers. The interference fit had been broken. The 50 microns of space Camilla had carved out with the flame had been enough to turn a solid wall back into a door. The rear door didn't just swing open. It popped. The internal pressure of the climate control system, which had been fighting against the hermetic seals for the last hour, finally won the battle. The heavy slab of armor jumped outward half an inch, breaking the flush aerodynamic line of the bodywork. A sharp hiss of escaping air cut through the garage, the sound of the fortress surrendering its vacuum. The beast was no longer a prison. It was just a car again. The siege was broken, not by a line of code or a hydraulic ram, but by the application of basic thermodynamics. The door hung there, slightly ajar, suspended by its massive hinges, vibrating slightly from the force of the release. For a heartbeat, the garage was paralyzed. The reality of the open door took a second to override the expectation of failure. Then, the training took over. The security detail collapsed on the vehicle like a breaking wave. Agents were shouting clear codes, pulling the heavy door wide, their bodies forming a protective corridor for the extraction. It was a chaotic explosion of motion and noise, a sharp contrast to the precise, quiet work that had just occurred. In the middle of that storm, Camilla simply stepped back. She didn't pump her fist. She didn't look for a high five. She closed the valve on her torch, the hiss of the gas vanishing into the noise of the extraction, and began wiping the nozzle with a shop rag. The governor emerged, blinking in the harsh garage lights, his suit jacket discarded and his shirt dark with sweat. He looked shaken, the claustrophobia of the last hour etched into his face. He was ushered quickly toward the backup SUV, a flurry of movement that left the limousine standing open and empty. The crisis was over. The VIP was safe. The politics of the situation were already engaged, scanning for scapegoats and heroes. But Camilla wasn't watching the politician. She was watching the metal. She ran a hand over the B-pillar again, checking the temperature decay, ensuring the heat hadn't spiked enough to damage the clear coat permanently. The manufacturer's technicians stood frozen, staring at the open door as if it were a religious apparition. They moved closer, their tablets hanging uselessly at their sides, their screens still displaying the same diagnostic loops. They ran their hands over the B-pillar, expecting to find warped steel, blistered paint, or the charred remains of the wiring harness. Instead, they found only the faint, chalky residue of the thermal paste and a lingering warmth that was already dissipating into the cool air. They were looking for the trick. They wanted to know which wire she had jumped, which sensor she had bypassed. They couldn't compute that the solution had been purely analog. They were staring at the discoloration on the pillar, the physical evidence of the thermal expansion, trying to reconcile it with their digital worldview. Camilla wiped the last of the thermal paste from the pillar, revealing the paint underneath. Undamaged, perhaps a shade duller from the heat cycle, but structurally intact. She looked at the lead technician, who was still gaping at the latch mechanism, his mouth slightly open. "It's not magic," she said, her voice cutting through his confusion with the weight of experience. "It's clearance. The metal wanted to move. It just needed permission." She packed the torch back into the canvas roll, the brass clinking against the steel wrenches. To them, she had performed a miracle. To her, she had simply negotiated a truce between the temperature and the tolerances. The garage began to settle. The adrenaline that had fueled the security team was fading, replaced by the dull fatigue of a crisis averted. The smell of the thermal paste hung in the air, a sharp chemical tang mixed with the scent of warm ozone. Camilla tightened the leather strap on her tool roll. She didn't wait for a thank you. She didn't need the validation of the suits. The head of the security detail found Camilla wiping the soot from the brass nozzle of her torch. He looked different now, less like a coiled spring, more like a man who had just realized how close he came to a career-ending disaster. The arrogance of the timeline had vanished, replaced by a quiet, terrified respect for the physics he didn't understand. He didn't ask for a receipt. He asked the only question that mattered to a man whose job depended on reliability. "Is this going to happen again?" He was looking at the beast with suspicion now, viewing the armored fortress not as a shield, but as a traitorous object that might turn on them again. Camilla didn't look up from her tools immediately. She was meticulously cleaning the threads of the gas valve, treating the $50 vintage torch with more respect than the manufacturer's team treated the $2 million prototype. She wiped a smudge of thermal paste from the nozzle before answering. "It won't happen today," she said, her voice echoing slightly in the emptying garage. "The metal is awake now. The heat is in the frame, and the interference fit is broken. But next winter? Or the next time you park a black car in the direct sun for 4 hours and drive it straight into a refrigerated bunker? Yes, it will happen again." She stood up, sliding the torch into its leather loop and tightening the buckle. She walked him over to the open door, pointing to the striker plate where the faintest haze of heat discoloration remained. "This is your problem. You have engineers in a climate-controlled lab in Detroit designing tolerances for a perfect world. They chased micron-perfect security. They wanted a seal so tight that air couldn't pass. But when you build a machine this rigid, you don't make it stronger. You make it brittle. Not structurally, but functionally. It lost the ability to adapt to its environment." Across the garage, the OEM technicians were huddled around a cell phone, frantically speaking to a senior engineer at headquarters. They were using words like anomaly, unverified thermal event, and external interference. They were trying to translate what had just happened into a language their database could understand. They couldn't log butane torch into their digital service ticket, so they were inventing a digital phantom to blame. They were already rewriting the history of the failure to protect the reputation of the electronics. They would likely replace the body control module, swap the actuators, and bill the state $50,000 for repairs that fixed nothing, all to avoid admitting that a $60 torch and a basic understanding of thermodynamics outsmarted their entire diagnostic suite. Camila watched them with a faint, tired smile. She didn't despise them. She pitied them. They knew how to read the output, but they didn't know how to feel the input. They were safe in their clean theories, while she lived in the dirty reality of friction and heat. The machine wasn't broken, Camila said, hoisting the heavy canvas roll onto her shoulder. The weight was familiar, comforting, the density of real steel tools. It was just stubborn. It didn't need a reboot. It needed a conversation. It needed someone to negotiate with the metal instead of ordering it around with voltage. She turned to the lead agent, offering a final piece of advice that wasn't in any manual. Next time, don't park it under the vents. Let it acclimate. Treat it like an old dog, not a tank. It'll serve you better if you respect its joints. She walked toward the exit ramp, her boots heavy on the concrete. She was a ghost of the mechanical past, walking away from the confusion of the digital present. Behind her, the garage was returning to its normal rhythm. The fans spun back up, cycling the air. The radios chirped with all-clear signals. The limo was being prepped for transport, the door closing with a solid, reassuring thud now that the heat had loosened its grip. She didn't look back. She didn't need to see the taillights to know the job was done. She could feel it in the silence of the steel she left behind. The beast was tamed, not by force, but by understanding the language it spoke. As the governor's limo finally rolled out of the garage, the locking mechanism hummed perfectly, the tumblers sliding home into the warm receiver plates with effortless precision. The thermal seizure remained a secret kept between the specialist and the steel. If you respect the difference between changing parts and understanding physics, subscribe to Unsung Fixers to see the repairs the manuals don't cover.